Hello, let's continue our Sudoku adventure with Siege by Wuschel. So it looks like a lot of rules, but they're just very detailed. I'll go through them, but they're really not that bad. So we do have normal 6x6 Sudoku rules, meaning in each row, each column, and each 2x3 box, we are placing the digits 1 through 6 exactly once each. We also have these region sum lines in the grid. As you move along the line, as you pass by these bold borders, basically as you enter a new box, you create a new segment. So this is how this this is how this line would segment, because as you move into a new box, you create a new segment, and each segment on the line has the same sum as each other. On different lines, there can be different sums, but on the same line, they're the same sum. So if this was 2, 3, that sums to 5, meaning that all of these sum to 5. So you'd actually just immediately put a 5 in these two. This could be like 1, 4, and this could be also 1, 4. So as long as they would all add to 5, right? So whatever their sum is, all of them have the same sum. So that's region sum lines. We also have min and max cells. Min cells are just smaller than all the surrounding cells, the ones that share a border. So whatever this is, say it's a 3, these have to be bigger than 3 in that case, like 4, 5, 6. Obviously, Sudoku allows you to repeat digits. This would be fine too. And then the red ones are max cells, so they're just bigger than all the ones around it. So whatever these 4 cells are, this is bigger than all 4 of them. And that's it. Those are the rules. There's a link in the description if you'd like to try the puzzle yourself. And I'm going to get started right now. I'm interested in how these min-maxes affect our region sum lines. The first thing I'm going to do actually is I'm going to mark these both as green, because as I showed in my rules example, these have to be the same sum as each other. They're one cell. Sorry, they're the same sum, but because they're one cell, they're the same digit. So whatever green is, it's the same digit in both of these. Now I'm noticing that this green is next to a red max cell, and this green is next to a blue min cell. So they can't be 1 and they can't be 6. I think not being 6 is more interesting. They already couldn't be 1. So just naturally, they're 2, 3, 4. They're not 2 either. They're 3, 4, or 5. The minimum we could add 2 is 1, 2. Okay, but we have this min cell here. Now, the thing about min cells is you can't put a 1 next to a min cell because it would have to be smaller than 1. So these can't be 1, meaning the minimum we could add to is actually 5, and that's the maximum these can be. So we end up with 2, 3 adding to 5. So this is 2, 3 or 1, 4. So are these. Now, this can't be a 1, so that can't be a 4. Can I resolve this in any way? This just has to be bigger than them, so that's not a big deal. I'm going to get rid of the green. I don't need that. 5 looks down through here. Oh, this has to be a 1. Okay, that's helpful. That means that's not 1, so that's not 4. 5 looks down here, putting the 5 in there. When I said the 5 looks down, I was going to see if 5 could go in there, and then I realized it's a min cell, so it had to be the 1. That places the 5 here in this box by Sudoku. 5 is placed here. Can I finish the 5s? Yeah, 5's placed here. 5s are done. What about 6s? Oh, this 5 does make this a 6. That places the 6 here. This is a 4, just to finish the box. That can't be 4, so that's not 1. So this is a 2, 3 pair. It makes this one 4. So this is a sum of 5. This is going to be 1, 2, 3, 4. I could argue by uniqueness that it's not going to be 1, 4, and 1, 4, because there'd be no way to resolve them. But we're not going to do that. We're going to prove it some other way. This 6 looking up does place the 6, since it can't go on here. Let's actually think about this for a second. What would be wrong with 1, 4? Actually, I think it's actually pretty clear. Probably the question to ask is, whatever this cell ends up being. In fact, let me color this. Let's make this green. That makes this purple, green, and purple. Might be helpful. Where does green go in this box? Green looking into this box, it's not here. It's not the 5, 6. So green has to end up on this sum to 5, which means that this is a 2, 3 sum. So it actually has green and purple on it. Cool. And this purple looks up. So that's green, and then this is purple. So purple ends up here in this box, and in one of these two. Green is one of these two. This is a 1, 4 pair. Oh, we can't put a 1 next to a min cell, so that's 4 and that's 1. So this is smaller than 4. I mean, the 1, 2, 3 is always going to be smaller than 4, so not a big deal. Yeah, this is just 1, 2, 3 by Sudoku. This is 4, 5, 6 by Sudoku. I guess it's just 4, 6. So this is 2 or 3, so this has to be smaller than it, so it can't be a 3. That puts the 3 down here. So this isn't 3, making that not 2, for what it's worth. Do we need to know about like green or purple or something? Purple's in one of these two. Oh, purple is not on our sum. It's in one of these two. Therefore, this can't be a 2-3 pair because 2-3 pair has purple on it. So this is 1-4. This is 1-4. This is 3. That's 6 and 4. That's a 2, making that 3 and 1. All our purples are 2 now, which means this is actually not purple. It's green. It makes that a 2, and all the greens are 3, of course. All right, well, let's finish the puzzle. We need a 6 here. We need a 6 here. This is our 3. That can't be green. 3 in the corner, deep dudes. 1-4 pair, so this is our 4, this is our 1, our 1 and our 4. We're done. Oh, that was neat. I definitely feel like the key step was, where does this green go in this box? It ended up here, but it had to be on the line. Kind of what prompted me to even think about that, though, was the kind of the uniqueness argument there. So I knew it had to be 2-3, so by thinking about 1-4, it became pretty clear that that would have broken things in non-uniqueness argument ways. So kind of neat that it pointed me there. All right, cool. For posterity, let's just make all the 2s purple and all the 3s green for those watching all the way through. There's your reward. All right. This actually looks a darker purple because it's on top of a blue. But anyway. Well, I enjoyed this. Let me know how you did. And if you enjoyed it, why not leave a like, subscribe, and a kind comment below.